So 1A.5 is a add-on to that. Does that make sense? So that's why we check for your memorization on how to do a regression model, because 1A.5 adds on to that. And when you're taking your unit assessments, you won't have those steps there. So you need to make sure you're comfortable with navigating through to put the data in as correctly as possible. So I'm going to tell you what to write now. All right. We have two parts of notes. Part one is TI-84. The second part is decimals. They all should fit on this one page of notes in your handy dandy notebook. So up first is TI-84. So we're going to go over linear. We already talked about linear regression. Now we're going to talk about how to find a quadratic and exponential regression model in the calculator. Okay. So we're going to go over how to find quadratic and exponential regression models in the calculator. We're going to be using, these are our notes for Friday, but we're going to be using the tables today. Does that make sense? So I'm going to give you this paper, but these are for when? Friday, okay? But we need the tables 1 and 2 to do our assignment. Okay, I'm going to put up the notes and I'll let y'all write them down and then we'll go through them. Is that cool? Yeah, okay. Here you go. So what we're going to be doing is we're going to input our table. After we input our table, we're going to change our settings. And the settings that we change are underneath mode. After we change our settings, when we go to stat calc, there are going to be three options that we see there. You'll have linear regression, quadratic regression, and exponential regression. And we're going to run all three of them. Sorry. You only can run them one at a. Okay. I'm going to open up my calculator. So here is Sylvie coming at you. Hey, girl, hey. I'm going to reset her. Second plus 712. Second plus 712. Okay. It says we're going to use the tables. Ignore where it says page 14, and that's relevant. I did a poor job of updating. We're going to be just using the table pattern notes. Okay. So, table 1 is what we're inputting. Do we all see table 1 on the paper I gave you? These are the values that we're going to input into our stat edit. So we're going to go to stat edit, like we've been doing, and we're going to input in the values. So I put in my X and L1 and my Y's and L2. Like I skipped a number. What did I skip? Oh, I skipped 3. Oh my gosh, 3. 12, 27, 48, and 75. Okay, so again, I put in my values under stat edit. Okay, after I put in my values, I'm going to change the settings of my calculator. Okay, so I put in the values and I'm going to change the settings of my calculator. I'm going to mode. I'm going to go where it says float and I'm going to lock it in at 3. Then I'm going to go to stat diagnostics. And I'm going to turn it on because currently it's turned off. Anyone need help putting the mode stuff? Good? All right. Then it says when we go to stat, it's supposed to be the emoji arrow. Don't know why I like decided to be a hater. We're gonna go to calc. So we're gonna stat calc. I'm gonna go to stat, arrow over to calc, and you can see we have linear is at 4, quadratic is at 5, and then you can't see exponential, but if you scroll down, exponential is at 0. Do we see that? Okay, we're going to first run a linear regression model. So I'm going to start at 4. And then I'm going to go down to calculate. So it's going to calculate, and it's going to give me the values of my linear regression model. So we're going to write the equation. It says y equals a. Well, what is a? 15 x plus b. And what is b? Negative 10. So there's my regression model, my linear regression model. Are we good? Now, when we turn on our stat edit, notice that it added this information here for us. We wanted the r squared value. What is our r squared value? 0.921. What that tells us is that how well of a model we have. So it's an okay model. It's not 100%, but it's a decent model. Now we're going to run a quadratic regression model. So we're going to repeat the steps again. We're going to go stat, calc. This time we're going down to quad, which is 5. I'm going to run the calculation. I'll hit calculate.
Whoa.
And it says our equation is y equals ax squared plus bx plus c. So y equals, well, what's my a? What's my b? And what's my c? Is there any point of writing them? No. And this time, what is the r squared value? 1. Okay, okay. In terms of percent, what does a 1 mean? What does 1 mean in terms of percent?
0.01.
It means 100%. 1 means 100%.
Oh, wow.
Yeah.
So,
Yeah. It's just 1. So it's 100%. So that means that based on what we have here, the quadratic is 100% the best model. Does that make sense? All right, now we're going to do exponential. So I'm going to go to stat, calc. I'm going to press 0 for exponential. And what does it tell you?
no.
Error. That means it's not even possible. Okay. There's no way that exponential can fit this model. So we're going to just put NA for not applicable.
Oh, really? I thought that I got scared. I was like,
how do you feel about running not just linear, but also quadratic and exponential regressions in the calculator? Pretty easy. Okay. The reason for the stat edit is because of the R value. Okay. We want to look at the R squared value to determine how well the data fits the situation. And that's why we're making sure we can see that and we can analyze the R squared value. Okay, so clearly, which had the better R squared? Quadratic. Easy enough? How do we feel about TI-84 linear regression given at least 2 points? Doable? All right. The next model, so you can just draw a line, because now we're going to move on to Desmos. So in your notes, you can draw a line. I'm going to give you a moment to write down Desmos. Desmos doesn't run on a click of a button. It runs on you typing in certain rules for it to follow, okay? Am I good to go?
okay.
You good? So Desmos, you're going to input your table as usual. Do you remember how to input the table? We're going to plus, it's the big plus sign, right? You're going to put the big plus sign on the left to add your table. Then you're going to find your regression models. And there are 3 models you have to know. You have your input for linear, which we've already learned, right? Y1 tilde mx1 plus b. We got that one, right? Quadratic is a little different. Here's quadratic. It is y1 tilde ax1 squared plus bx1 plus c. Okay? To make the power, you're going to press Shift 6. You're going to press Shift and 6, and that's how you make your squared power. And then our last one that I'm going to let you write down is your exponential. I'll give you a moment to write those down before we move on to Desmos. If you have them written down and you feel good to go, you can go ahead and... All right, so we've put in our graph. We're now looking, and the linear has a pretty low r squared value. Do we see that? All right, so now we're going to do the quadratic. Y1 tilde ax1 shift 6 squared plus bx1 plus c. Okay, looks a little better. My r squared value did increase, didn't it? So it went up. Okay, now we're going to do our exponential. Y1 tilde AB shift 6 x1. Oh my gosh, graphically I can see it. And what is my r squared? 1. So does that tell me about the exponential model?
It's better.
It's perfect. 1 is perfect. And that's how you do it in Desmos. You thought I was joking when I said it would go really fast, didn't you? Nope, it was that easy. Mark our text. So we know we have 500 listens, and that's on the day he released it. So this would be our 0, right? Our A, because it's our 0, correct. Then we have 1,725 listens on 5 days. And what we're looking for is our exponential function model. And then how many does he have 21 days later? Okay. All right. So the first thing we're going to talk about is remembering our format is y equals a times b to the x. Okay. For the sake of this, I don't use b because my b looks like a 6. So when I start plugging in numbers, it looks weird. So you would see I use y equals a times c to the x so that my b doesn't look like a 6. Does that make sense? All right, cool. All right, what is a again? A is going to be 500 because a is always your initial, your value at 0, right? So first thing we're going to do is make our table to identify our x and our y's. So at 0, we have 500. Then at 5, we have 1,725. Agree? Okay. Our 0 is our a. Yes? So we know we have y equals 500 c to the x. What we have to try to find is our c, our growth factor. What is our growth factor? In order to do that, we're going to substitute in our given values and solve for c. So they gave us 5 for x and 1,725 for y. So we're going to substitute in. So y is 1,725. We have 500. We don't know our c, but we know our x is 5. So we're plugging in. Now, instead of having 3 unknowns, we only have 1 unknown. And our job is to solve for that 1 unknown. Okay? Yes. So we made our table. We created our first model. And then we're plugging in to solve for that, right? So step 4 is now to get c by itself. So what are the steps I need to take to get c by itself? This is multiplication. We're going to divide. Remember, when you are undoing, you got to start from the bottom of PEMDAS. So you're working your way up. You can't touch the power until you've dealt with your multiplication and your division. Does that make sense? So we're going to divide both sides by 500. And we're going to leave it as a fraction. 1,725 divided by 500 equals C to the 5th. Now, is my C by itself yet? No. How do you get rid of a power? So if it was a 2, we would take the square root, right? But is this a 2? No. So we're actually taking the 5th root. Whatever the power is, that's the root you're taking. So we're taking the 5th root. Does that make sense? Okay. So in the calculator, in order to put this in, we're going to press math, and then we're going to press 5. Okay. And that's how we're going to find our C value. Yes, ma'am.
What's the thing outside the?
My little 5.
Oh, that's a 5.
Mhm.
It's C to the 5th.
Okay. If you're on Desmos, you cannot type this in. So if you choose to do this on Desmos, you have to write it as a fractional power. So in Desmos, it would be 1725 over 500, and it would be to the 1/5 power. Okay. So on Desmos, you have to write it as a fractional power. We got that? But in our calculator, we're pressing math 5. So I'm going to pull out good old Sylvie. You don't put in, C's not going in. Okay, so I'm going to go math 5, and I'm going to type in 17. Oh, I forgot my 5. I'm going to put my 5. Then I'm going to type in 1725 divided by 500. Okay, it's going to give me a value. Oh, sorry, my mode is not set right. I need to be rounding to 3 decimal places. So they'll figure it out. Or they won't. Huh? Math 5. Remember? We're gonna press math 5.
So what you get the you get to use the root in this problem.
Why are we using the root?
Yes.
Because we're getting rid of the power. To cancel out a power, you use the root. Okay, they're inverses of each other. Okay. Mimi. Okay. All right. So I have 1.281. Did we all get that? Okay. Did y'all notice how? All right. So now we have our C value, and because we have our C value, we can now write our full equation. Does that make sense? So we know C equals 1 and 281,000. So our equation is Y equals 500 times 1, 281 to the X. Okay.
That's it. It's the X.
Your first part is to write your model. If I'm writing a model, there isn't a value yet. Yeah. So the thing is what is your exponential function model? In order for it to be a model, I need to have an independent and a dependent. So now we did that part. Now we can answer the 21. Does that make sense? Okay. So now we can answer the 21. So we created our exponential model. Now step 6 is, if there's more to go, it says 21 days. Can I now figure out where it's at in 21 days? Yeah. Yes, because I know if X equals 21, what happens, right? So I'm now going to plug in Y equals 500 times 1 and 281 to the 21. Does that make sense? Yeah. Okay. This is your model. This is you answering a problem. Okay. For a model, you must have your independent and dependent variable. All right. What do we get? A lot of views, a lot of listens, right? So if you need to see it modeled, all we did was type in 500 times 1 and 281 thousandths to the 21 power. And we get 90,677.
You wouldn't round, right? I mean, it would just be like the whole.
You could round up. Yeah. So it'd be 90,678 listens. He's blowing up, y'all.
I'll be rapping on that 10 of
All right. Yes. Yes. So on this one, you round to the whole because they're lights, and you can't have a part of a light. Does that make sense?
Yeah.
All right. Okay, on to the next one. All right, so this is a weird problem. Megna has a lot of cats, and her cats has fleas. Just gonna let you know this. Each of Megna's cats has fleas. Her veterinarian recommended a treatment plan that includes combing out her cat's fur every day. Megna decides to track the number of fleas she's removed from her cats while combing them. On day 0, she started the treatment. She removed a total of 87 fleas. On day 6, she removed a total of 14 fleas. If Megna keeps up the treatment and the number of fleas can be modeled by an exponential function, approximate the number of fleas she should expect to remove from her cat on day 14. And write the exponential function and show all your work, okay? So let's go through and mark our text. On day 0, we have 87 fleas. On day 6, she has 14 fleas. So they're declining. The medicine is working, right? And it wants us to find out day 14 and create an exponential function, right? Agree? All right. So I'm going to help you set up the table, but then I want you to look at our example 2 and go from there, okay? So on our table, we have 0 and 87, and we have 6 and 14. So from our table, because we have 0, we know that our A equals what? 87. Okay. All right. I'm going to walk around. I want you to go from here and do the rest. Are we ready to be released, or we want to keep going? Keep going. You're not ready to try by yourselves?
I think we should.
I think you can. I think you can. I believe in you. All right, go. Okay, so for our C value, to find your C, 14. For your C, you should have did the 6th root of what?
14 over 87.
14 over 87. Did we get that? And what did we get approximately for that value?
0.738.
0.738. Yes. So then my equation is y equals, my model is y equals 87 to the x. So we did the model. It's 2 parts. You telling me the model, and then you solve. So yes?
Yeah.
All right, now we're solving for, on the 14th day, how many fleas are left? So now, when x equals 14, what do I get? So we have 87 times 0.738 to the 14th. And what do we get? We have, but can you have a fraction of a flea? So we're just going to say there is 1 flea left. So the treatment is working, right? So we see it'll be dead.
It's more like a flea and a half. Right.
Okay. Either way, 1 flea, guys. We're going to stick to 1 flea. All right. So our first example 1 was of a growth, right? Yes, we agree that's a growth.
Yeah.
Example 1 was a growth. How do I know it's a growth? But how do I know from the function that it's a growth?
That it's more than 1.
There you go. Good job, Randy. My growth factor is more than 1, so it's a growth.
I think I remember.
This one is a decay because my growth factor is less than 1. Okay. All right. I'm going to get you set up on the peer do, and then I'm going to let you go from there. Okay. The reason why this one we're going to set up together is because it's a little different. Do I have any volunteers on reading?
I don't know how to read.
Thank you, Lily. Lily's going to read for us. Hit it, Lily.
Naomi is a social scientist who is studying how a rumor travels through a community. Naomi tracked that 7 people had heard the information 2 days after it was introduced to the community. She tracked that 11 people had heard the rumor 5 days after the information was introduced to the community. Write an exponential function that Naomi could use to model the scenario and use it to predict the number of people who have heard the rumor 20 days after the rumor was introduced to the community.
Awesome. All right. So this one's a little different, right? Because does it actually say we have a starting value?
No.
It does not. It tells us that she recorded 7 people in 2 days. time is generally your X, okay? Time is generally your X, no matter if it's days, months, minutes, seconds, time is generally our X, okay? So 7 people on 2 days, 11 people on 5 days, and it wants us to create an exponential function and find out 20 days later, right? Now, the key thing here that we have to pay attention to is we have 2, 7, 5, 11, and we want to know 20. Because we don't have a 0, we're going to force our 2 to be our 0. So we make 2 our 0. If 2 is our 0, what does that make 5 become?
Our 8.
3. It becomes 3 because it's 3 days past it, right? And then therefore 20 is going to be what? 18.
18.
Because 20 minus 2 is 18, you know? All right. So now these are the values we're using. Does that make sense? So when you're not starting at 0, you force it to start at 0, but you have to account for how far it is from there. All right. I'm done talking. Now solve.
You're done talking, so that's going to be 8.
All right. So the key setup here, when you set it up, it should have been y equals your 7 c to the x, right? Then we plug in what we knew. We know that our y is going to be 11 equals 7 c to the 3rd, right? Why is it the 3rd? Because we made 2 our 0, correct? Then, so our c equal the cube root of 11 divided by 7. Agreed? All right, what do we get? There we go, 1.163. So then our equation is y equals 7 times 1 and 163 thousandths to the x. So we found our model. Now that we have our model, can we figure out how far the rumor has spread by day 20? Yes, and so we got what? 106. So if we let x equals 20 days, well, not x, 20 days means that x equals 18, right? And so we end up with 106 people knowing the rumor. That's how rumors spread, right? This is actually kind of a slow spreading rumor if you think about it. Okay. All right, this is you completely, no help. Okay. This is you from start to finish. My only hint for you is remembering that I have to force it to change, right? So keep in mind, it doesn't start at 0. I have to make my 0. Yeah. So when we looked at the information, we had 1979 was 23%. 2019 was 35%. It wants us to create a functional exponential function model. And it wants us to find out 1995, right? So 1979 is going to be my 0. Agreed? So therefore, 2019 is going to be what? 40. And then 1995 is going to be what?
24. 92. 16. All right.
Oh, well, 1995 minus 1979. Is it not 16?
16. I didn't know.
Okay. So remember it, because we have to change it from, force it as our 0. So we had 0.23, we had 0.35. So based on what we see here, should we be expecting a growth or a decay? We should be expecting a growth, right? And we question mark 1995 because that's what we're trying to find, right? Okay. So we are going to plug in what we know. So for y, we're going to use
1940, 79.
We're going to use, it's my 9. It just didn't make it. So 0.35 equals 0.23 c to the 40. I know you're like 40. That's huge, right? But guess what? We don't have to solve it. The calculator does, correct?
Okay.
So our c equals the 40th root of 0.35 divided by 0.23. And what do we get for our approximate C value?
Okay, we're going a little too fast.
You were supposed to have did it already.
I was going to, but you weren't fast enough, right?
What do we get?
1.01.
1.002.
1.01. Yeah, that's what
I literally said that.
1.01. Oh, yeah.
Yes. So then our exponential model is y equals 2300 times 1.01 to the x. There's our exponential model. Now that I have my exponential model, can I predict for 1995?
1995.
Yeah.
Okay.
And what do we get?
It'll be to the power of 16, right?
It would be to the power of 16.
I knew it. I literally had it written down.
So 1995. Yes, I was.
What'd you say?
Means x equals 16 and we get what? There we go. 0.274, which is what in percentage?
27.4%.
27.4% of the population.
And so I need to go find one of these people.
All right. Yes. Feeling it? Is it terrible?
Yeah.
All right. Last one for you guys to do. And we'll check back, but that's it.
2 minutes left, Michelle.
Oh, I believe in you.